Okay, what value of x will f at x and g at x intersect? Okay, so that's the same thing as making f at x and g at x equal to each other and solving for x. Okay, so let me write that out. That's equal to the 20x cubed minus 200 x squared plus 300 x minus 200. Okay, so there's only one x to the power 4 term, so that stays exactly the way it is. Okay, now let's collect the cubic all on the left side. So minus 17 plus 20, bring it to the left side by subtracting both sides by 20, we get minus 37. So that's taken care of. 27, okay, and minus 200, bring it to the left side, and we get plus 227x squared minus 252 plus 300. So that gives you minus 552x. Again, the minus 200 comes to the left side. By adding both sides by 200, we get 432. Okay, very large value. Okay, we can't reduce it because I see an odd number here and an even number here. So now we have to resort to rational zero theorem. And let's let this be our p at x. Okay, and if you check 0, we get a large value, 432. Okay, so we want to get closer to 0. Let's plug in 1, and we get 72. Okay, still positive. Let's plug in 2, and we get minus 28. Okay, so that means by intermediate value theorem, there has to be a root between 1 and 2, right? At 1, the graph was positive. At 2, the graph was negative. So it must have went through the 0. So what, by rational zero theorem, what roots are there? What rational roots is possible with the coefficient of 2 and the last constant term of 432? Well, 432, let's break this down. Right, 2, 1, 6. Okay, so 2 over 2 gives you 1. We need something bigger than 1. I think 3 is a factor of this as well. 7 and 2. So 3 over 2 is exactly between 1 and 2. So we should try 3 over 2. Okay, and you can do this with a calculator. When you plug it in, we actually do get exactly 0. Okay, so let's do synthetic division with 3 over 2. Okay, so 2 multiply, we get exactly 3. Add, and we get minus 34. Multiply, and we get, that's 17 times by 3. That's 51. You get negative 176. So now let's multiply to 3 over 2 again. 264. Okay, let's add this. 288, and finally if I multiply it in, I get a minus 432. Great. So note that our factor is actually not x minus 3 over 2. But if we were to divide the polynomial by x minus 3 over 2, this would be our answer. We get 2x cubed minus 34x squared plus 176 minus 288. Okay. However, what we did divide by was 2x minus 3. Okay, and we can get that by just factoring out a 2 from here and multiplying it in here. So we get 2x minus 3. If we divide everything by 2 here, you get x cubed minus 17x squared plus 88x 144. Okay, so we have to keep going. Okay, so what number will factor this? By rational zero theorem, it's strictly factors of 144. So 144 is 12 times by 12, right? That's 2 times by 6, 2 times by 6, so 2, 3, right? 2, 3. So we can try 2, 4, and then it'll be 6, and then it'll be 9, okay? Okay, so if you plug in 0, you get 144, negative 144. Quite negative, so we want to make it more positive. You can see that if you plug in 2, it's not going to do it. Okay, it's still going to be quite negative. So you want to plug in something that's larger than 2. And you can quickly plug in 3 as well, and that won't do it either. Okay, so let's plug in 4. And when you do plug in 4, it does work out. Okay, it does work out. So let's use synthetic division, okay, to get what the remaining factors are. Okay, what our quotient is. 1, negative 17, 88, negative 144. So 1, 4, that gives you minus 13, that gives you minus 52, that gives you 6, 3, and that gives you negative 144, positive 144, 0. So we get x squared minus 13x plus 36. Okay. And actually this is now trinary factoring. That works again. So we get 2x minus 3, x minus 4, another x minus 4, and x minus 9. So completely factor form is this. Okay, finally we can state our answers. Answer is going to be, for this equation to be 0, it's going to be 3 over 2, 4, and 9.